So the first 4 rules are the ones that we've already done. Okay, the ones that we've already done in 4.2. So let's review them real quick because we've done them already. If you want to ask questions, please ask questions. The first rule can be thought of in several ways. The first idea is that it's a product of powers. So there's a product occurring of 2 things that have powers. The key for this rule is that the bases have to be the same for this rule to take effect. So if you want to write down a quick note, the note here is that the base is the same. So look at the rule. The rule has A as the base in both of the factors. And when multiplied, we simply add the exponents. And if I want to prove that to myself, whenever you forget a rule, just write it out. Literally, look what I did. I wrote it out, and that proves the rule. X squared y cubed times x to the 7th y to the 5th. Well, what does that look like? Do you want to do that every time? Obviously not, right? I would not want to be writing this on my test because it takes forever to write all those letters and then sitting there counting them. So if I do it though, if I forget for some odd reason, I can still come up with a rule. 2 plus 7 gives me 9. 3 plus 5 gives me 8. And if I'm not sure, count the y's. There's 8 of them. Count the x's. There's 9 of them. More.
Only when the bases are the same.
Only when the bases are the same. Which is why our answer had 2 different bases, didn't it? Because we started with 2 different bases. That's why x and y cannot be combined with one another. I could have different exponents and combine, and that's what we're seeing here. The exponents all different. It's the bases that have to be the same for this rule to apply. Okay, one that's a little more tricky. This is out of your notes, something that some of you got confused with. What about this? How about that? Moro, right away, Ben.
You drop the base and you just solve it.
Careful. You're interpreting it as an equation. It's not an equation. There's no equal sign, right?
Yeah, you solve it. I'm sorry, you drop the base and then just add or subtract the exponents.
In this case?
So it would be x to 3n minus 2.
Okay, good. So be careful what you're saying. You kept saying drop the base. You're not dropping the base, right?
Drop the base.
If you are knocking or canceling off the base, it's when it's an equation and you set the exponents equal because the bases will equal. You're not dropping off the base, okay? So we carry over the base, yes, and we add the exponent, just like we did in the rule. So n plus 2n gives me 3n. 2 plus negative 4 gives me negative 2. Okay, one that people have confused in the past a bit. Rule number 2, you just got to know at this point. You got to know it. And if you don't know it, you got to learn how to memorize. Anything to the 0 is 1. Any number to the 0 is 1. Okay? Yes?
Wait, so back to the first one.
Sure.
By base is the same. So what if it was 1 to the 3rd times 2 to the 3rd?
Can't do anything with it.
Oh.
You could evaluate that number because 2 to the 3rd is just 8, isn't it? So the answer is 8. But if it was x to the 7th times y to the 5th, can't do anything with it. Completely different basis. Okay? For this rule. If you want to see a proof or a generalization of why this rule is absolutely true, you can do this with any number. You can do number 3. 3 squared is 9, 3 to the first is 3. How are we getting that? We're dividing by 3. Okay, divide by it again, you go back to 1. Here it's divided by 2. Right, divide by 2, divide by 2, and there it goes. Anything to the 0 is 1. Anything to the 0 is 1. Rule number 3 and 4. Rule number 3. A power to a power. Again, if you forgot the rule, you can actually derive it. Look at what I'm showing you to show the rule. And it's very easy if you just follow this. X cubed raised to the 4th. What's the rule? Multiply. 4 times 3 is 12. I'm done. But if I forgot, write this out as x cubed, x cubed, x cubed, x cubed. And there it is. And then what's the rule applied to this? Well, same bases. So I go back to rule 1 and say, just add the 4 exponents. 3 plus 3 plus 3 plus 3 yields 12. So if you forget that 3 times 4 is the rule, you can write it out like this and come up with the rule and the answer itself. So when in doubt, write it out. Okay, for exponent stuff. When you're stuck, just write it all out. And the last rule for this section is called a power of a product. So in this case, this is very much like distributive. It's not the same, but I want you to almost think about it that way. If I have AB as a quantity to the C power, I'm raising each of these to that power. Because each of these are factors. A and B are factors. Only when we have factors, meaning a product, inside of the parentheses, raised to a power, can I take that power to both factors. If there were a plus sign, and this were A plus B to the C, I cannot distribute the C to both. That is an example where I have to FOIL it out. For example, let me write it down so we can see the difference here. Look at this, please. 2x to the third. And then look at this. 2 plus x to the third. Are they the same thing? Do they look the same? No. So the answer cannot simplify the same way. So on the left-hand side, if I raise 2 to the third, it's 8. X to the third is x to the third. How do I take care of the right-hand side, though?
2 plus x, and then in parentheses 2 plus x, and then parentheses 2 plus
Yeah. I got to FOIL, get one answer first. Right? I got to FOIL this guy. And then I got to do triple distributive here. So this is a much lengthier process, right? I got to still do triple distributive on the right-hand side. Distribute the 2, 1, 2, 3. Distribute the x, 1, 2, 3. 6 terms, collect like terms. Very big difference. Very common mistake. The mistake I see all the time is that students write 8 plus x cubed. They literally just distribute the cube to both. This is only allowed, you can only apply the cube to both things if those things are factors, not if they're terms. 2 is a term, x is a term when separated by a plus sign. But when separated by multiplication, we call these factors. Factors can be individually raised to said power. Terms cannot. Terms cannot. And to see the proof of that, just look up here. The quantity 4 times 2 cubed. Well, I could do 4 times 2 first. That gives me 8. And 8 cubed is 512. Or, instead, 4 times 2 cubed, you could do it this way. Take the 4, cube it. Take the 2, cube it. 4 cubed is 64. 2 cubed is 8. 64 times 8 gives you 512. Either way, it's the same answer. So I can multiply what's on the inside, then raise it to the power, or raise the powers, then multiply. Again, this is an example with numbers, whereas we are looking at examples with variables. So it's not easy to prove this rule with only variables, but with numbers alone, we can prove the rule is true if this works. Let's get to the new stuff now. Number 5. How many of you know this already? Show of hands. How many of you know this rule from previous school or in general? Okay. If you've memorized subtraction, that's all right, but I'd rather you honestly forget it. And let me explain the reasoning here. A lot of teachers tell you subtract. Top minus bottom, every time. And you know what? That's okay until the top is less than the bottom. You get a negative answer, and then students get confused with the negative exponent, which we're going to get to also. So the way I'd like you to think about it instead is this. Imagine this. Okay? Common mistake is to answer x squared. The common mistake is to give an answer of x squared, where the student takes 8 and divides by 4 and says it's 2. And you guys know that the rule tells you to subtract the exponents, right? The rule says subtract. And that's fine. 8 minus 4 is just 4. So the answer is definitely x to the 4th. But here's how I want you to start thinking about it. Think about it in your head. You're not going to write this down. I'll write it, but you don't write it. Or you could write it, but write a note that you're not actually writing this out. Think about it like this. This is what I want you to think about. Because that's what's happening. And when you have a common factor in the top and bottom, what can you do to that factor? If it's common amongst the top and bottom, what can you do to that factor?
Cancel them out.
Yeah, look, cancel, 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 cancel. How many are left? That's where the rule comes from. The rule of subtraction, meaning 8 minus 4, is literally just canceling 4 of the bottom ones, which are all there are, with 4 from the top, leaving 4 behind up top, which is where the subtraction comes from. So again, yes, memorizing subtraction, totally fine. But the minute we start working with negative answers, it's going to be messy. So I want you to think about cancellations, please. Think about cancellation. So if I had something like this, okay, something like this, a simple example, no numbers involved, all variables, no powers outside of a parentheses, something crazy. A simple, what I call example, simple. What do we get? What do we get when we do this?
X to the 6th times y to the 6th times z to the 6th.
Yeah, they're all to the 6th. All 3 of these are the 6th, because again, 8 and 2, 2 of them cancel with 2 of them, leaving 6 behind. 7 and 1. One of these y's cancels with one of these, leaving 6 behind. Well, how many z's are in the bottom, really? None. Z to the 0 means there are none actually there. Anything to the 0 is just 1. There are no z's down here to cancel up here, leaving all 6 behind. If I'm on a standardized test, and this isn't there as an answer, what am I looking for then? There's another way to write this. If I'm taking a standardized test, and this choice does not show up,
X, Y, Z in parentheses, and it's the 6.
very good, Eduardo. Okay, keep in mind that when you take a multiple choice on this test, your answer may not be the way it is represented. So these two things are absolutely identical, and they're both right. Is that clear? They're both correct. Because I know that when I have a power outside of a product, this gets distributed to all 3, x6, y6, z6, that's what you have here. So either interpretation is correct. If it's a multiple choice, you need to find the one that actually matches up to the multiple choice options. Yeah? Questions on this? So to go into rule 6, I want you to think, okay, I want you to think about the next scenario where more exponents in the top. Where there's a higher power in the denominator, a higher power in the denominator. So if we have a degree of 6 in the denominator and a 4 in the numerator, we have to recognize here that, yes, subtraction works, right? Subtraction works. What's 4 minus 6? It's negative 2. So this m to the 4th, I use m, by the way, so you go, when you read that. M to the 4th over m to the 6th, you subtract 4 minus 6, you do get negative 2, which is fine. But most tests do not give negative exponents as answers. You're going to see that a lot more often. AP, standardized SAT, ACT, they give answers with positive exponents. So this rule then kind of leaves me a little bit, left up the creek without a paddle. I'm like, oh, I got a negative exponent, none of those choices are there. So instead, please look up, instead, I'd rather you interpret this the way I've been telling you to. If there's 4 up top and 6 down below, cancel 4 up top. Cancel these 4 that are up top with 4 from below, leaving behind 2 in the bottom. And that gives me an answer. When I all cancel on the top, what's left up top? There's a 1. Remember, whenever you cancel factors, a 1 is always left behind. That leaves a 1 up top, and in the bottom it's 1 times m, yielding 1 over m squared. So again, depending on which way I do it, it looks like I get different answers. But they're not. They're the exact same answer. M to the negative 2nd is the exact same thing as 1 over m squared. These are the same. This is going to lead us into our next rule. Okay, recognize and write down, if you didn't know this already, that when you have a negative exponent, you can simply move it to the opposite position in the fraction and make it positive. This one started in a numerator. I've now moved it to the denominator and make it positive. If it starts negative as an exponent in the denominator, move it up to the numerator and make it positive. So let's take that knowledge in second to last rule. So I give two interpretations of the rule so it's easy for you to understand. The first interpretation is the one that we just did. If you've got a negative exponent, move it to the bottom and make it positive. But if that negative exponent starts in the bottom like this, you take it and move it to the top and make it positive. This is the converse? Is that the right word? Not the converse, no. It's another interpretation of the rule. So the two that I've circled are the first interpretations. So write yourself a note in words, please. If you have negative exponents, just move the position and make it positive. So if it's up top, move it below. If it's below, move it up top. Again, if it's up top, move it below and make it positive. If it starts below as a negative, move it up top and make it positive. Let's quickly look at an example of that, and then we'll do the other part there. So an example could be something like this. X to the third, y to the second, over x to the negative third, y to the third, z to the negative fifth. And the problem might just say simplify the expression. This is like a standard question 1 through 15 on an SAT. One of the easier ones. What do you think I should do here? What do you think I should do? Julia?
Move the x to the negative third to the top and z to the negative fifth to the top. And then...
So what's left in the bottom?
Y to the third.
Good. And then, go ahead.
And then you have to combine the two x to the thirds and you get x to the sixth.
X cubed times x cubed is x to the sixth. Agreed?
Times y to the second times z to the fifth over. Well, you can cancel.
Yeah, so I would probably cancel this y squared with two of these, leaving a y below in the bottom.
Yeah, and then you just have z to the fifth.
There it is. Okay, that would be my answer for this problem. Yes, you could have just canceled these to start, obviously. We just didn't move them at first. So Julia started by moving all negative exponents. You could have started this problem by canceling the y's and leaving the y behind and then move the negative exponents. That's fine. You could have done 3 minus negative 3, which is really 3 minus negative 3 is 6. And that would give you the 6 if you want to memorize the subtraction rule. Okay? That's the first way to interpret the rule. The second way to interpret the rule, let me put a little line in between. The second way to interpret the rule is here circled in yellow. That's the other interpretation. And what this says here is the following. This says that if I ever have a fraction and the whole fraction is to a negative power, it's the same thing as moving everything and making it a positive power. Because remember, a negative power means moving. If the negative's on the outside, take a look here, the negative's on the outside, this negative c gets distributed to both this and this, which makes this a to the negative c, a to the negative b, which I would then want to switch their positions to make them both positive. Okay, so that's where the switch comes into play, making this a positive. So you switch it and switch the sign. Okay, switch the top and bottom and then switch the sign. Again, these rules are not difficult, but you need to have them memorized. This can't be something on the test where when you get to the problem, you get stuck and can't proceed. Because this will kill you on your time. You need to be going through this very, very quick. Okay, like it's second nature. Questions on numbers 4, 5, or 6. Rules 5 or 6. Yeah? All right, rule 7. Yeah, Regina, go.
I don't get the part that's circled in yellow.
Okay. In yellow, what I'm saying is this, Regina. Really, this would become a to the negative c over b to the negative c, right? And then that, because they're both negative, I would switch them, which would become b to the c over a to the c, right? Which really is just back to this right here. Okay, so instead of distributing the negative to both and then flipping them and making them both positive, I can at the same time distribute the negative and flip them both and write it this way. Just kind of a shortcut. That's all. But you could distribute the negative first. That's fine. Either way. It's a good question. Others? Yeah.
If there was already a negative exponent inside of the parentheses.
And a negative on the outside?
Yeah, so would you just move them upside down the same way so that you're keeping the negatives and negative and the negative?
Sure. Or you could recognize that there's a double negative there, right? And only move the one that had a positive. So if it was like b to the negative 2 in here, well, I could just make that b to the positive 2, make that a positive c, and it's like I moved it twice, right? Yeah. Either way is fine. As long as you interpret it the right way, which is what you did. The last one is a power of a quotient, and we just did this actually. We literally did this in the last slide. It's the same exact thing as the power of a product. Write yourself a note, please. Write a note. This is identical to rule number 4. Same as rule number 4. Number 4 is power of a product. This is power of a quotient. The rule is the same. The rule is the same. If I have factors, I can distribute the exponent. A and B, believe it or not, are factors. Remember that division is defined as multiplication by the reciprocal. So actually A and B are factors. So that C as an exponent can get applied as an exponent to both terms, the numerator and the denominator. Let's look at an example that's a little more complicated than this. Let's put a couple of our rules together in the process. Let's say x cubed, y squared, all over, y squared, y squared, x to the negative 3, all to the 4th power. That's an x there, sorry. Stupid of me. I made them both y squareds. Make the numerator y to the 5th. Change that to a y to the 5th, please. So in this process, I have to consider the fact that I've got an exponent outside of a product and quotient now, right? There's quotients going on in the top and bottom, but there's a product in the top and a product in the bottom. So I have to consider my rule. Question or answer? Hold on. So I want to recognize in a problem like this that I can take many different approaches. I can start with simplification inside of the parentheses. Or I can start with distribution of what the exponent is. Personally, I would start with simplification first and then distribute the exponent on the outside. I would simplify it first. It just makes life easier. Y to the 5th over y to the 2nd gives me y to the 3rd. I'm going to put the x to the 3rd that's in the denominator as a negative. I'm going to take this right here, move it up top as a positive. X cubed becomes x to the 6th. What's left in the denominator? A 1. Okay, so do I have to write it? No. I'm going to put it there just for the sake of right now, but I don't have to. This becomes x to the 24th times y to the 12th. Remember, a power to a power, we multiply those powers. 6 by 4 is 24. 3 by 4 is 12. So this didn't even involve a quotient in the end. But let's say that, you know what? I'm a different student, and I want to take the root where we distribute first. So let's do this a second way. So let's do it the other way where we would distribute the 4 first. Raising all those powers to powers, we have to multiply all those numbers. So x cubed to the 4th is x to the 12th. Y to the 5th to the 4th is y to the 20th. In the denominator, it becomes y to the 2nd to the 4th, which is y to the 8th. And x to the negative 3rd to the 4th is x to the negative 12th. So that's what I would get if I did it this way. But I can recognize that I can continue to simplify this. I've got y to the 20th over y to the 8th. 20 up top, 8 down below. What's left over?
12
Where?
on the top.
Good. Again, 20 up top, 8 down below. These 8 cancel with 8 of these, leaving me how many behind? 12. 12 down below is a negative. What do I do with it? 12 down below is a negative. What do I do with it? Good. Bring it to the top. 12 up top, 12 up top, they're both up top, that's 24 up top, and there's the 24. So whichever way I choose to approach this, I will get the same answer if I use my laws of exponents the appropriate way. Question on this section as a whole. Yes?
Would it make any difference if the constant was negative?
The constant. Where is there a constant?
I mean,
Yeah.
like x, x1.
So if x or y's were not variables and instead they were negative bases, is that what you're asking? So for example, if I had negative 2 cubed times 5 squared all to the third, like that?
Yeah.
Well, if it was numbers, to be honest, Valentina, I would probably just figure out the values themselves first. Negative 2 cubed is negative 8, times 25 is negative 200. Negative 200 cubed is going to be negative 80,000, whatever it comes out to. So I would do them individually. But if you had like something like this, because I know what you're asking really. If you had something like this, like that instead, then you got to do negative x times negative x times negative x. And negative x times negative x times negative x is a negative number. If it was just negative x times negative x, it would be a positive number. So this will yield a negative number, and then that negative number is to the fourth, which will yield a positive number.
And so you said that if the bases aren't the same, they can't.
So the 3 and the 2 cannot be combined there. Correct.
So if x, let's say, an example of x to the 12, if x was negative and x to the negative 12 was another variable, and x was negative, we could do it.
Sorry. So like that and
If
that.
one was like positive and one was negative,
So like that. Does that work? So can you cancel? Is that what you're asking me?
so it could be after two.
All right. Theoretically here, yes, because this is really to the even power, which makes this a positive answer. But if I make this instead of 12 like an 11, right? Like that, if I make it an 11 instead, what I can do actually is I can group the first 10 and then have the 11 at the end. And I could cancel actually. So what this becomes, negative 11, negative x to the 11th is really six of them, and you'd end up with x to the fourth times negative x, which is negative x to the fifth. Last part makes sense? Where I'm getting that? So this reduces to x to the fourth times negative x, times negative x, which is really negative x to the fifth. Because this is like saying x times x times x times x times negative x. Well, there's only one negative, which makes the whole thing negative, and there's 5 x's, so you can simplify that. Okay? Regina?
Will this be on our test?
It will, indeed. This is the last topic for the first semester. It will be on your test and on your midterm.
I mean, like, the bottom.
Anything is on your test, though. You guys could ask any question right now that involves this, and it could theoretically be on your test. Because all of these, if you apply the rules properly, will give you the correct answer. Okay, so the rules are really important that we understand them. It's rare that I push rules, if you've noticed that. I'm not a big fan of like following rules in math. I'd rather you understand it more. So I've been teaching you the methods to understand it, but the understanding allows for 7 rules to come about. So it may be useful for you for simplicity reasons and quickness on tests to actually have the rules somewhat, if not fully memorized.
No, I'm talking about the rules. I'm talking about like
Yeah, any of that's fair game, yeah. Because again, the rules give you the answer, so. Take a look at the homework, please, okay? Tomorrow, your problem sets are due. This homework is not due until Monday. All right, 4-9. Let's go back to that last example, please. 4-9.